vector, but optimized for rapid insertion and deletion. Lists are designed for fast insert and remove operations, and they do not support random access. Let's make a working copy of list.cpp. I'll paste it into our working project here. So let's go ahead and compile and run this so you can see what it does. And there's quite a few things going on here, so let's walk through and take a look at them. So up here we're including the list header on line 3. And on line 11, we declare and initialize a list object, li1. And so you see it's declared as type integer. And we initialize it with 10 integers, 1 through 10. And then we display the size, the front, and the back. So like other containers, it supports front and back. And you see down here, front is 1 and back is 10. And then we can use the pushback method to add another element at the back of the list. And so we add a 47, and then we see the size is now 11 and back is now 47. We can iterate through it with the range-based iterator, or using the iterators in a normal for loop will work also. And there you see the result is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 with the 47 at the end that we added. For most operations in a list, you need an iterator or two. So here we're declaring a couple of iterators, it1 and it2. And in order to insert before the element that contains the number 5, we iterate through the list with this empty while loop until we find the element that has a number 5 in it, and then we insert another element before that. And then we loop forward until we find the element with a number 7 in it, and then we delete the element number 7, and then we print them out again. And so you can see that now we have the 112 before the number 5, and we've deleted number 7. If we want to erase everything in a range, we want to erase all these elements between 112 and 8. For this, we need 2 iterators, so we initialize both our iterators to the beginning, and we use empty while loops to step through the list with the iterators. And as long as we haven't hit number 112 and we haven't hit the end, we loop forward with iterator 1, and we do the same thing with iterator 2, looking for the element that has a number 8 in it. And then we display them both because now we've found them both. So here we have the erase from line 42, and there we display the 2 elements on line 46, so we can see that we've found them with our iterator. And now that we've found and confirmed that we have the right elements, we do the erase. And you'll notice that it erases everything from 112 to the element just before 8. It does not erase inclusively. So if you want it to erase inclusively, you need to increment iterator 2 just before you do the erase operation. So I could save that and run it, and you'll see there we've now erased everything, including the number 8. So it looked like that before, and everything from here to there. So now we have 4 and 9 right next to each other. We can initialize a list from a C array, just like you can with a vector or other containers. So here we have a C array, and we've initialized size up above here someplace, probably up at the top. There it is, constant static int size equals 10. And there we display all the elements in that array. So that array is now called li2. We can initialize an array from the argv argc list, just like we can with a vector. And here's another common operation that you will do with lists, popping things off the top of the list and displaying them. And these are actually 2 separate operations because pop does not return the element. And so you have to display the element first and then pop it. And so here we have our list of strings, and we're popping them and displaying them. So STL lists are an excellent choice for situations where you don't need random access, and you'll be inserting and removing a lot of items. They're very fast and lean, but at the expense of some functionality. Now let's delete our working file.